Now, dear student of class 12, now today I'm going to start the derivative of parametric equations. Now say, what kind of functions are called the parametric functions or the parametric equations? Suppose, now the example is over here, x equals to ft and y is equals to phi t. That means x is variable, y is also variable. In this case, t over here, t is a parameter. The parameter not only t, but it may be t, theta, and you will get three different forms of parameter in mathematics. When you get this kind of equation, x in terms of t, some function in terms of t, y, some function in terms of t, and if you ask to differentiate, if you ask to find dy by dx, then you have to differentiate the given functions with respect to t. Now I'll differentiate both the functions with respect to t. Differentiating both the equations with respect to t. X with respect to t, now we can write dx over dt is equals to derivative of ft is f dash t. Similarly, y with respect to t will get dy by dt equals to phi dash t. Now what we have to calculate? Dy by dx. You just have to remember this formula. Dy by dx. To calculate dy by dx, we'll write dy by dt over dx upon dt. Now then substitute. Dy by dt is over here phi dash t over dx by dt is f dash t. This way we can calculate the derivative of a parametric equations. Now it's a kind of function, these are the function and these are the method of solving of parametric equations. Now the numerical that we'll do. Now the question is x equals to t cubed by 3 and y is equals to t squared by 2. What you have to calculate? Dy over dx. Now both the equation I'll differentiate with respect to t. This I'm going to rove equation. Now differentiating with respect to t, both the equations that you have to differentiate with respect to t. X with respect to t is dx over dt is equals to derivative of t cube is x to the power n formula 3 t to the power 3 minus 1, it is 2 over 3. Get cancel. Now it is t square, the value of dx over dt. Same way I'll differentiate another functions. Y is equals to t square by 2, then it will be dy by dt is equals to derivative of t square is 2t by 2. Cancel. Now it is dy by dt is equals to t. What you have to calculate next? Dy by dx. Dy by dx is given by always dy by dt over dx over dt. If you cancel this dt, you will get dy upon dx. Now what is the value of dy by dt? It is t. Dx by dt is t square. Let's get cancelled. The answer is 1 over t. Here in this case, now say the x is in terms of sin theta and y is in terms of cos theta. So what you have to do is you have to differentiate. Now in this case, theta is the parameter. Differentiating both the equations with respect to theta. X with respect to theta, that you will get dx over d theta. A derivative sin theta is cos theta, dx upon d theta. Similarly, y with respect to theta, that you will get dy over d theta. B and derivative cos theta is minus sin theta, minus b sin theta. Now next we'll calculate dy over dx. Dy over dx is given by dy by d theta divided by dx by d theta. Now then substitute the value of dy by d theta is minus b sin theta. Dx over d theta is a cos theta. Now it is minus b upon a sin upon cos, can write tan theta. Now in this question also, parameter is theta. Now both the equations that I'll differentiate with respect to theta, differentiating with respect to theta, what I'll get over here, dx over d theta. A, first you have to differentiate the power functions. Cos cube theta means first power, x cube is 3x square. Same way, cos cube theta means 3 cos square theta into derivative cos theta is minus sine theta. Now after simplification we'll get minus 3a cos square theta sine theta. Now another function, same way that you have to differentiate, but it will be dy by d theta. B, derivative sine cube theta is 3 sine square theta and the derivative sine theta is cos theta. After simplification we'll get 3b sine square theta cos theta. Next we'll calculate dy over dx. dy from dx is dy by d theta over dx by d theta. Now then I'll substitute. Dy by d theta is 3b sine square theta cos theta over dx by d theta is minus 3a cos square theta sine theta. Now next is the cancellation, numerator over denominator form. 3 get cancelled, cos and this cos get cancelled, sine and this sine get cancelled. Now it is minus b upon a. What remain over here after cancellation? Sine theta over cos theta, it is tan theta. Now in this case, theta parameter is theta, but you have to find dy by dx at theta is equals to pi by 2. That means the method is same, but in final answer that you have to substitute theta is equals to pi by 2. Now I'll differentiate both the equations with respect to theta. Differentiating with respect to theta, dx over d theta is equals to a theta with respect to theta. X with respect to x is 1. Same way the theta with respect to theta is 1 plus derivative sine theta is cos theta, dx over d theta. Now I'll differentiate this one. This one will be dy by d theta is equals to a, and derivative 1, any constant, is 0, and derivative cos theta is minus sine theta. Now minus a sine theta. After the derivative, now we'll calculate dy upon dx. dy upon dx is given by dy by d theta over dx by d theta. Now then substitute the value. Dy by d theta is minus a sine theta over a into 1 plus cos theta. This and this get cancelled. Now we have over here the value of dy over dx is minus sine theta over 1 plus cos theta. But now we have to find dy by dx at theta is equals to pi by 2. So I'll substitute over here. Dy by dx at theta is equals to pi by 2. In final answer that you have to, in place of theta, that you have to write pi by 2. Minus sine pi by 2 over 1 plus cos pi by 2. Pi by 2 means it's 90 degree. The value of sine 90 is 1 plus cos 90 is 0. 1 plus 0 is 1, it is minus 1. Dy by dx at theta is equals to pi by 2 is minus 1. Now this question, it's look like complicated one, but now if you use inverse trigonometric formula, this question will be very easy. This is just a 2 marks type question. Let's say sine inverse 2t over 1 plus t square. We did these things in inverse trigonometry. Now we can convert 2 tan inverse x in terms of sine inverse. Formula is sine inverse 2x over 1 plus x square. can convert these things in terms of cos inverse also. Cos inverse 1 minus x square over 1 plus x square. And in terms of tan inverse 2x over 1 minus x square. We did these things in inverse trigonometry chapter, inverse trigonometric functions. Now videos are there, you can say the videos, you can revise these things. Now 2 tan inverse x we can convert in terms of sine inverse, in terms of cos inverse, and in terms of tan inverse. Same way, sine inverse 2t over 1 plus t square, using this formula, sine inverse 2x over 1 plus x square is 2 tan inverse x. Similarly, x equals to, we can write sine inverse 2t over 1 plus t square is 2 tan inverse t. Same way, y is equals to tan inverse 2t over 1 minus t square. Say tan inverse 2x over 1 minus x square is 2 tan inverse x. Similarly, tan inverse 2t over 1 minus t square, we can write y is equals to 2 tan inverse t. It's not necessarily that you have to do with the previous method. Another method, easy shortcut method I'll do. X equals to 2 tan inverse t, y is also 2 tan inverse t. That means y is equals to, now using this, comparing these two relations, we can write y is equals to x. After getting y is equals to x, then differentiate with respect to x. dy by dx, and derivative of x is 1. If you use parametric form also, you will get the answer 1. If you use this text, you will get 1. And one more thing, from parametric equation, I'll do this much of numericals. Next class, next video I'll upload on Saturday, and the video is functions with respect to the functions. But please, student, please try to follow the all the previous videos also. Then only you'll understand the calculus. If you skip some videos, then you'll not able to understand the further topics. Please see all the videos. Try to watch all the videos. It would be better if you download all those videos, then revise it, and then further you can go easily. Now after this derivative, I'll go directly integral calculus, and without knowing the derivative, integral calculus is not possible. Please watch all the videos, okay? And Saturday I'll upload another one, and the topic will be the functions with respect to the functions. Thank you.